Hi everyone, my name is Huseyin, coming from Turkey. So I am a software developer. Basically, I am building Kubernetes products for the developers. So a little bit about me. I am building software since 2007. I started with basic web development, and then I shifted to something like software as a service project for a long time. And I have worked for big scale companies like Sony and eBay before for their DevOps and microservice transition project. I worked as software architect for them. And since 2016, I just realized that there is an option for us to work remotely. So I am working remotely since then. Around since that time, I am building software as a service products. So since this remote working also opens lots of gates for us, for developers, and I managed to travel lots of places around the world while working. So it is a real good feeling. And I like to do gardening in my spare time, and I am doing regular Twitch streams, and you can see me also on YouTube. Of course, they are all related to software development. It's too fast. Okay. So in this session, what we will do is, let's say that you are a solo developer and you just want to introduce a micro SaaS, for example. And what kind of steps you can apply to achieve your project. So it includes maybe a couple of examples, especially in Go. You will see Terraform examples. And also you can see there will be lots of technologies. Of course, I cannot deep dive them, each of them, but you can see real useful examples so that you can use them as a reference. In our step-by-step explanation, there will be configuration. You can see logging, artifact generation, CI/CD examples. Of course, there will be infrastructure as code. And since you will earn money from your product, there will be a payment system. Okay, I will use this one. So let's start with the project folder structure for this kind of automation. First of all, you can maintain this infrastructure as code on a separate repo, or you can even, if you are using a monorepo notation, you can put a separate folder, for example, named IAC, and then you can put all the infra-related stuff under that folder. As you can see, there is a control plane cluster here. You can extend this. It can be control plane cluster dev, prod, maybe there can be data plane cluster. And you see there is a module. So under the modules, we will have our commonly used modules among our infrastructure projects. And there are three more files: inputs, main TF, and versions. Let's take a look what happens in these files. In versions, you can think that they are just naming conventions, by the way. If you take a look at the Terraform modules, Terraform, some examples, you can see these versions TF, inputs TF, they have this kind of naming convention. In versions TF, this is the dependency file, as you think. So under the required providers section, you can see we have Google and Kubernetes providers, and we specify their names and we specify their versions. So when you do that, they will be downloaded from the Terraform registry when you do Terraform init and the other commands. We say required versions. For example, if you are using Node.js, there is an engine version there, or if you are using a Java, there is a source target version or source version, something like this. So this is the version of the Terraform itself, and it is semantic version. There is one last section, which is cloud. We will be using Terraform Cloud for this. Of course, you can use the other notation. You can maintain your Terraform state in some kind of, you can even in your computer, you can maintain them in storage system like S3, Google Storage, whatever you need. But here, I don't want to deal with that kind of side costs. So that's why I am using Terraform Cloud for this purpose. And I state my organization and the workspace name. You can have multiple workspace names in Terraform Cloud. In inputs.tf, as you guess, this is the file that contains the parameters. There can be optional parameters, there can be required parameters. So in my end, since I am using Google Cloud, I need region, external secret. This external secret, something that maintains some kind of credentials for Google Cloud project. There's a Cloudflare API token, Postgres password. I just show one part of it, but as you guess, we will be tackling with Cloudflare stuff, we will be tackling with Google Cloud stuff, and all the parameters are here. And I will also show a demo for that. In Terraform Cloud, you can define variables. So when you execute your, if you trigger a run on Terraform Cloud, that variables that is injected to this run, they will be automatically assigned to this execution. So variables are delegated to this run, then continue to execution. What about module folders? You can see there Argo CD, backup, budget, database, DNS. Maybe even you are using resource. Let's say that there's a resource like Helm release. It is used for installing a chart in your system. But even you are using Helm, I just want to convert them into modules because it becomes easier to reuse among my projects. Especially if I am using a monorepo, then it is very easy to just reference to that modules and use it in all of the places. Here you can see my modules. In each module, when you open it, you can see there is a main TF, there is an input TF, and there is a version TF if needed. For example, there might be some kind of modules and they don't need any kind of inputs. What about usage? Think about now this is the control plane cluster. So if you are building a software as a service project, there is a term which is called control plane and data plane. Control plane is the place that you deploy your applications. Let's say that your microservices. And the data plane is the place that you maintain your actual technology that you provide your customers. For example, you are Redis as a service, and then data plane contains Redis instances per your customers. They are totally isolated. The control plane is microservice pool. You can think there is something like deployment service, user service, payment service, invoicing service. This kind of stuff can go to control plane. Now in my control plane definition, when you take a look at that, I am saying module. Two examples of the modules. One is DNS record and another is database. In DNS record, as you can see, I am referring to a module that is already relatively in my current project. And I provide a couple of parameters there. Some of them coming from variables and some of them coming from the data. I don't know if you ever used Terraform before, but mainly there are two sections there, resources and data. When you take a look at one of the providers, you can see two sections, data and the resource. Resource means you are about to create a resource on your system. Data is for use the query purposes. So if you have a Kubernetes cluster, you need the Kubernetes cluster credentials. And I am using data here to refer Kubernetes cluster, get the credentials, and most probably it is something like, okay, the load balancer. I need a load balancer because I am about to create a DNS record. In the value section, that's why I am using data Kubernetes service and the remaining part. And database, you can also create a database. In my end, I am using Postgre and I just wanted to maintain it in my cluster. But you can also prefer to use software as a service version. For example, if you are on AWS, you can use RDS and you can connect to RDS instead of maintaining your own database. Okay. So this was the overall picture of folder structure and what we are doing, how we are using modules. Now think about you are about to build a project by using Go. So you do Go mod init and your module name. This is something like npm init, or if you are using Maven, for example, you can just create a project by using Maven artifacts. So the very important part of your application, this is configuration, right? Because you should be very careful about using the correct credentials, correct configurations for each of your environment. As you can see, for the configuration, there are lots of libraries, but in Go, you can take a look at, there's a conf library. So what it does, basically, you can have YAML or JSON notated configuration, and they are simply deserialized to a simple struct. So this is a simple POJO, let's say, that it is a model. So the configuration is automatically mapped to the struct in this case. So in our program, you can use YAML or JSON files, and as well as you can override this configuration by using environment variables. And remember, is there anyone already heard about 12-factor app before? Okay, the remaining part also, if you are related to DevOps or, I don't know, the platform engineer or SRE, you should really take a look at what is 12-factor app. So in 12-factor app, as far as I remember, the third option is configuration over environment. So if there is a configuration for your application, just try to maintain this configuration by using environment variables. So if you are deploying, you are creating a deployment in your Kubernetes environment, then you can pass your configuration through the environment variables. If you, let's say, that inject your configuration into application, then if you need to change something, then you need to just rebuild your image. Or think about this. You have dev, staging, and prod environment. So if you are not using configuration over environment and you are using static credentials, let's say that, inside your project, you may need to build your Docker image again and again. Here, as you can maybe guess, underscore refers to indentation in the YAML file. For example, app, and there is an ident, there is a port. This refers to application port. And all the letters are camel case. So for that, uppercase. So this configuration also can be mapped to same struct. There is no difference. So we have an application. We are able to configure it. And now let's take a look. If we want to deploy our application, we need to have a good observability on top of that, right? If there is a problem, we need to understand what's going on there. Here, this is again just an example, but if you use any kind of library, login library, just try to understand what kind of features do this library has. For example, by default, they may print your logs in a plain text format. But if you are using a logging backend in a distributed system, in a Kubernetes environment, if you have a plain text logs, it can be a bit hard to parse on the logging backend. So you are shipping your logs to some kind of backend, like Elasticsearch, like Graylog. If you are using plain text, then it can become a bit hard to parse them. For example, you are shipping an error log, but they are acted like an info log on the logging backend because it cannot parse it properly. But if there is a JSON format, JSON logging option, then it will be best. Of course, readability may be a bit will be a bit decreased, but in your local you can use plain text, and in the other environments you can use JSON format. When you do that, you can inject a couple of context there. For example, there is an error, failed to fetch quiz questions. The context is user is John. So you can provide key value pairs to this configuration. The logging statement. Then, since we have logs, we will produce lots of logs, of course. And here, who will collect your logs? We are in Kubernetes environment, basically. And then you can automatically collect all kind of logs and ship to destination. There are a couple of options for this, but you can use, for example, FluentBit. You may heard about maybe Logstash, FluentD, the other parameters, other technologies. But here, FluentBit, it is just a collector, and it can collect these logs from different destinations, different sources, and it can ship it to different destinations. For example, it can read your container output logs. It can read logs from files. It can read from different technologies. You can take a look at what are the integrations, and you can easily ship it to destination. For example, Elasticsearch and AWS or Graylog or other, I don't know, some kind of REST endpoint. You have your own logging system, maybe. So here, I am using Helm release resource, and then the name is logging, just an arbitrary name. And I am providing my Helm chart repository. I'm providing a name Fluent, and the chart name is Fluent bit, and the values files, of course. If you have environment-based values file, you can just use it. Okay, this was the environmental configuration. So we are able to ship our logs if there is any. We can pass our configurations to application. But what about artifacts? I mean, do you have any kind of system? In Go, for example, there's a Go releaser, but on other technologies, I'm providing as a reference, but you can just map it to other languages. For example, in Java, there is J releaser. On other languages, most probably there is one alternative. But here, basically, we create a Go releaser YAML file, and the only thing you need to do is just Go releaser build, release, and dash clean. It will build the artifacts and clean everything that will not be used in the production environment. Here, just an example. These IDs are important because there is a cross-reference between build stages. For example, if you build something and then you will push it to some destination, then these IDs are becoming important. Here, I am saying that my entry point is cmd API main.go. The binary name will be Quasar API, and the operating system will be Linux, and the architecture will be AMD64. You can extend it, by the way, according to your needs. The previous one will generate the artifacts, which is the binary executable. But what about the Docker image generation? Because we will ship it to Kubernetes environment. As you can see, again, there is an ID. I'm providing operating system architecture. And you see there is an IDs section. So it refers to previous section. And it will use that binary executable, and it will generate a Docker image by using the template. For example, image templates will be used for generating Docker image. So you can see this image in your GitHub container registry, because I am using this GitHub container registry. You can pass some build flag templates. So I am passing a couple of them to make it visible to me. Extra files. So normally, when you are using Go releaser, it will use only the binary executable. But in my case, I need an additional file, which is config dist YAML. So that's why I stated that in extra files. Skip push false. By default, it will be skipped. But if you remove it, it will be pushed to destination, which is GitHub container. I already provided full URL, so it knows where to push it. Maybe you may want to apply some kind of code quality check before pushing the image to the destination. For example, in Go, there is Golang CI lint. Maybe you have heard about that library. It is an abstraction to linters. Same kind of strategy happens on the other side. In JavaScript, you can see the linters in, for example, JavaScript, sorry for that. For example, Java, you can see check style. Lots of alternatives on this. But again, you are creating a configuration file and you are saying which linters you want to apply. You can configure all of them, so each linters have their own configuration. You can say that, for example, if a function has more than 35 lines, this is a big method. Or if a class has more than, I don't know, 100 lines, then this is a big class. So, or it can calculate your cyclomatic complexity, and you can provide a threshold. For example, 30. If it reaches 30, then your build will be failed. So here in this example, this is a complete GitHub action. What I am doing here, if you create a pull request or if you push something to remote, it will spin up an Ubuntu image, Ubuntu machine, and this machine will have read contents and package write permission, because I am about to push my Docker image to my repository, so it will be attached to that. And I am simply checking out to repository. I am setting up Go runtime, because I will need Go for linter, for building images, and whatever technology you are using. And most probably there is a GitHub action for that. So before doing your manual operation, just check the GitHub action marketplace if there is any alternative for that. Then I am doing Docker login and Go releaser. Docker login needed because I need to log into GitHub container registry first, and Go releaser will do the remaining part, which is building image and push it to remote. After this part, you will see this is my monorepo, and it contains In main branch, there is no that folder, but it contains all the source code. And on the right-hand side, you can see there is a new release attached. This is a normal release. And when you take a look at the packages on the right downside, there is a Quasar API Docker image. When you do something on the remote, everything is prepared in one command. That's it. We built lots of things, but what about shipping them to remote? Of course, we will be using Terraform Cloud. I will show the examples, but as we said, we will be using a payment system on this part. There are lots of alternatives, but I mainly use Stripe, but you can map this logic to other payment providers. Here, if you are using Stripe, there are mainly two items, the subscription and subscription item. And there is a metering billing. In Stripe, there is a no-code notation, so you can achieve your payment system with zero code, mostly, nearly. What you do in Stripe, you basically create a product. For example, you are selling a Redis instance, or you are selling, I don't know, MySQL database as a service. And in Stripe side, you create a subscription or product. Let's say that one Redis instance, and what is there in this product? For example, request per second, or data size, or I don't know, throughput, latency. This kind of parameters can go to the subscription item. So if there is a product, you can list all the features. What are the available features for this subscription? You know, you can have 1, 2, 3 subscription model, and if anyone subscribe to your application or one of the subscriptions as a customer, there will be an automatic customer creation on the Stripe side. And once you go, it is something like single sign-on flow. They will redirect it to Stripe and subscribe one of them. They will provide their own credit card. You know, they are still on the Stripe dashboards, not on your side. And once everything is finished, you go back to your application. The customer goes back to your application. So you did nothing, almost nothing about your payment system. But you got a reference, let's say that callback ID, and you can use it to call if there is a subscription for the customer or not. If there is one, just mark this user as a paid customer, and then you can also put a subscription information, let's say the subscription ID. Here, in order to create a customer, for example, you can see here in the customer section, here we are about to subscribe a customer, right? You need a customer ID on the Stripe side, and there is a price. Let's say that you are about to create a subscription programmatically. You provide your Stripe key. By the way, in Stripe, you can use everything in the test mode. So in production, when you switch to production, everything will be same. So you can test everything what you see in the production in their test environment. Even they have test credit cards, you can provide them. Also, let's say that you created a subscription. Now you can send the usage information to this subscription, right? So here there is an implementation, of course, because you need to track your customer, track your user about what they are doing. If you created a Redis instance, you need to track them. When they shut down it, most probably you shouldn't send this metering billing to the Stripe side. This is for pay-as-you-go system. But if you have a static system, like they purchased an account and you have a static price per account, you don't need to do anything for this. Just let them go to the Stripe side, subscribe it, and that's it. Because Stripe will recurringly charge that to customers. But here I need to provide my billing there. Argo CD, you will have lots of pieces for your application environment, and you should have a proper deployment strategy. In this case, in Argo CD, there are a couple of custom resources. One of them is application. So, for example, if you have a user service, there might be a user service application in Argo CD. So in Argo CD, you basically define a template, and this once you install Argo CD, this custom resource definition will be also installed. You can see them in your Kubernetes environment. Here I am saying that there will be an application which is named Quasar API, it will be in Argo CD namespace. And I am providing source and destination. So source means here my GitHub repository, or as you can see, this is a Helm chart. Um, if you have ever used Helm before, you can publish your Helm charts into your GitHub repository as under the GitHub pages, or you can ship it to Artifact Hub, whatever you need. But here I am saying that my source is an Helm chart and URL is this one, and the target revision is 001, and the release name is Queezer API. So if Argo CD just detects a change on this Helm chart, it will automatically ship these changes to the destination, which is the API endpoint of your Kubernetes cluster, the current one, and it will be deployed to dev environment. For example, if the target revision is changed from 001 to 002, it will be shipped to the Kubernetes environment. It will be synchronized. Of course, if you want to deploy Argo CD, you can take a look at their operators or a Helm chart. It is very easy to install, and then it is same as other Helm charts. You don't need to there is no rocket science there. About confidential data, most probably you will have database passwords, you will have Stripe keys, backend, lots of form of this confidential data. You can use external secrets for this purpose. This is a project that mainly does this thing. Let's say that you store your confidential data in AWS Secret Manager or GCP Secret Manager or Azure, whatever, or Vault, which one you are using. There are a couple of providers there. When you deploy external secrets with a configuration like, what is my secret source? Okay, AWS. Here is the credentials. Then, whenever you do a change in the secret manager, it will be automatically synchronized to your Kubernetes cluster, and it will automatically create a secret. So there are lots of configuration for that. But if you are doing a confidential data operation, just remember there is an external secret project before doing anything manual. So you can create secrets, you can define templates, and whenever you do something, it can create secrets in, for example, 5 namespaces at the same time. You can share secrets between namespaces, and there are lots of options in this scenario. What about public access? You deploy a black box in the Kubernetes environment. By default, it is not accessible from outside. Okay, you just created a service, maybe load balancer, maybe node port, whatever notation you are using. Assume that in GCP, you just created an ingress, and it provides a public IP address, right? Now, you don't want to provide a public IP address to your users, right? You need to provide a fully qualified domain name. Here, again, I am adding a Cloudflare provider in my infrastructure as code project. After this point, Cloudflare record will be available, right? Here, zone ID, I don't know if you ever used Cloudflare before, but if you have anything related to domain, just again, think about Cloudflare. But if you are using, for example, AWS, you can use Route 53. There are lots of options there. But Cloudflare provides more than a DNS management, because it has TLS management, maybe WAF protection. If you want to provide DDoS, then you can use their modules. Even they have some kind of Lambda environment, Cloudflare workers. So here, I'm about to create a Cloudflare record. It is a DNS record, and I say the type will be A, because when you create an ingress, it will provide you a public IP address. Here, the value is static one. Name is Terraform, just an arbitrary name. And the zone ID. Zone ID is important because in Cloudflare, you define the website first, and then you define your records under this site. That zone ID refers to that site. And the TTL is 1 hour. When you do that, let's say that you have an example.com. When you create this resource, you will see terraform.example.com will be available, and then it will be pointed to this public IP address. What about certificate management? Because you have an application there, you have a Cloudflare record maybe, but there is no certificates. So certificates can be managed with a generic way, especially if you are in the Kubernetes environment. there is a cert manager, like external secrets, there is a cert manager. They are really cool projects. Again, you can use their Helm install. So here, time to time, I am showing Terraform, time to time, I am showing Helm, but you can directly move them or map them to Terraform or vice versa. In Helm install, we simply create a cert manager. So what it does, when you do that, like Argo CD, like external secret, it will have a custom resource. Here, our custom resource is issuer. I provide a name, and there is a solver section. This is the trick. There are lots of certificate management stuff, right? You can use Let's Encrypt, you can use, I don't know, Cloudflare. There are lots of solvers. You can take a look at their Cert Manager website for the full list. Here, I am using DNS01 Cloudflare. What I do, I provide my Cloudflare email and then API secret key ref. So I am not providing a static secret here. Instead, I am providing a secret name so that most probably that secret is coming from the GCP through the secret manager. So once you do this, Cloudflare will know what to do about TLS certificates. So on your Cloudflare side, you will have out of the box a TLS management system. So there will be no warning in your browser when you try to access terraform.example.com. We have an issue, but how can we map it? So there's an issue, but on which destination I need to issue this certificate? You can, you can have lots of application services there. In order to differentiate the requests, what do? You just define the ingress, right? There is only one load balancer, maybe a couple of them. And then when you get a request to this load balancer, it will be proxied to other services by using ingress definitions. Here, I am creating an ingress, name is Quasar API, namespace is dev, and I enable certificate issuer by using annotations. So, Huseyin, you just created this, how it is doing this certificate issue? Because once you install certificate manager, as I said, it creates a custom resource and there's lifecycle management there. And it automatically just watches the custom annotations there. They are mostly done with webhook admission. Maybe you have heard about that. If certificate manager just see cert manager IO/cluster issuer, it will automatically does one thing. Okay, just refresh the web configuration, just attach a TLS certification there. So I will show an example about this, and let's do the question section. So I have a Quasar example. I will. Assume that I need to change my control plane node count from 2 to something different. As you can see, I have an IAC folder here. Maybe I have to. Okay. I have IAC folder here, right? I'm creating a new branch. Is node. Okay, under TF main TF, so I have only one example in this part. I will change this 2 to, let's say that 5, right? Node change. Okay. Now I will create a PR, pull request for this. Okay, from 2 to 5, create a pull request, and I will zoom this browser to see. So, in your section, I already connected Terraform Cloud with my repository. I will also show it to you. As you can see, the Terraform Cloud and the CI build. I show you example about GitHub Actions. Most probably there will be an error on the CI build because I have an expired token there. But basically, what it will do, it will just do the linter stuff, build the binaries by using Go releaser, and it will ship it to the repository. But as you can see here, Terraform Cloud Provider run. When I see the details, it will automatically redirect me to the Terraform Cloud dashboard. You can see the run here. So it says me that, okay, I don't know how to shrink this, but let me show it to you. So on this side, you can see um, it is about to change the node count, and you can see the difference here. You can see the difference. It will do a node count change from 2 to 5, so you can see it already. So this is just a plan. There will be no apply, nothing else. But on each of your PR, you can just say, you can just validate if there is a problem or not in the plan section. I haven't any kind of filtering in the GitHub action, but the best practice is do not trigger infrastructure change on each pull request. So you can put a path filter in the GitHub action. There is such a feature. So if you change anything under IAC, it will be automatically trigger Terraform Cloud. Otherwise, it will not trigger anything. Okay. Once you merge it, as I said, there is an expired token, but still, let me try to merge the pull request. So in the runs, okay. As you can see, there is a plan there, and it's stacked. Not stacked, but I have a configuration that do not automatically apply the configuration. You can totally disable it, by the way. Here, the plan is succeeded, and it is waiting for my approval. So you can say confirm and apply here, and that's it. Everything is shipped to the destination. It will change the node count on the GCP, and that's it. I only changed the node count, but whatever you need, DNS, Argo CD, GCP budget, for example, right? You have an environment, and you need to create a budget so that if you reach that budget or about to reach your budget, you can get notifications. So these kind of things all can be automated inside the infrastructure, even your Stripe subscription, etc. Right? So in order to say your application is up and running, you need to be sure that all the dependencies are up and running. You can also include Stripe subscriptions there. So let's say that you have an outage, your region is completely destroyed, and you want to restart or recreate your environment. When you click that button, everything should be initialized there, provisioned there, including Stripe, DNS records, applications, login configurations, Argo CD, everything. Yeah, that's it. Thanks for listening. If you have questions, I can happily answer them.